Revisiting the Schmitt trigger, we can see that if we ignore the feedback resistor over there, we've got resistor 1 and 2 as a voltage divider, which causes this circuit to operate as a comparator circuit, whereby 1 and 2 will generate a reference voltage on the non-inverting, and then if the inverting is greater than the non-inverting, the output will switch into the opposite state, which is either the positive supply or the negative supply voltage. Here I indicated them as red and blue. When including the feedback resistor, what happens is I have to remember my output voltage can either be equal to plus V or it can be equal to minus V. Now, in the event that V out is equal to positive saturation, that means that the op amp will connect the output into that configuration. Output voltage is equal to the positive supply. That means that I've got the positive supply voltage connected to RF. What that actually does is we can see that this configuration now converts into plus V. We've got resistor 1, we've got the feedback resistor, which is connected to the positive supply, and that causes them to be connected in parallel to each other, and that will then connect to my R2 at the bottom, which connects to my negative supply voltage. So now, instead of one reference voltage, by having this feedback resistor connected, I have now allowed for a different value, because I have to remember in a parallel circuit my resistance is going to decrease. So we will have R total is equal to RF times R1 divided by RF plus R1, and that is going to give me that total resistance over there. Then that total resistance relationship with that second resistor R2 will determine what the reference voltage is on my non-inverting input. If my input voltage causes my output to switch to the negative, then what occurs is the output voltage switches to negative saturation. That negative voltage now feeds onto my feedback resistor, which in essence causes this circuit to switch to R1, which splits into R2 and RF minus V over there and plus V on top there. Now I've got to remember this is my reference voltage on my non-inverting input. So we can see we've got the exact same formula occurrence for my parallel, except now I'm not using R1 anymore, I'm using R2. So I've got RF plus R, or times R1 R2 divided by RF plus R2. So if I'm working out that value there, that voltage there, then I'm working with the formula V out is equal to beta times V in, V non-inverting. V non-inverting equals beta times V out. Now V out is either plus or minus V, and beta will be determined by the relationship of, in my blue or my negative scenario, I'll have R total divided by R 1 plus R total, and in my positive I will have R total divided by R2 plus R total. Because in both scenarios I'm using the total parallel grouping plus the individual series resistance.